Okay, so this video is going through how to draw a diagram of an ion-ion half cell. So I'm going to start off just by very quickly going through a solid ion half cell, just to recap how to do that, and then we can look at the differences between the two. So here I have a half equation, and I've got an ion and a solid. So if I was to draw that, that would be a solid ion half cell. So what have we got? We've got our solid copper as the electrode, and our copper 2 plus aqueous ions will be in the solution. If this was standard, we'd have to make that 1 mole per decimeter cubed. If we look at the equation over here though, you'll see we don't have a solid. Instead, the copper on both sides is in an ion form. So this is an ion-ion half cell, as opposed to a solid ion. So what do we do here? Well, we don't have a solid electrode. You might be tempted to say, well, you just make the electrode out of copper anyway. But that would get in the way of the reaction. Look, there is no copper here. So we can't make this electrode out of copper unless there's solid copper in the half equation, which there isn't on this right-hand side. So instead, we're going to make it out of platinum, and we do that because platinum is inert. So it won't get in the way of any of your reactions. It won't do any side reactions. And then each of our ions needs to go in the solution. And again, if this was under standard conditions, they'd both need to be 1 mole per decimeter cubed. So write that next to both of them, not just one. So what are the two main differences here? Well, the first one is rather than having your whatever the metal is as your electrode, we use platinum, as platinum is inert. And the second difference is we're sticking all of our ions in the solution, as opposed to here where you've only got one ion to put in the solution.